Lesson 2, Group 1, partial fractions with linear factors that are non-repeated. Part 1. Examples: decompose the following into partial fractions. Number 1, 3s plus 2 over bracket open s plus 2 bracket close bracket open again s minus 5 bracket close. Solution: you have the given compound fraction. The denominator, the factors are non-repeated. In other words, they are different. S plus 2 is different from s minus 5. For that reason, you assign two numerators to each one of them. So you have a over s plus 2. By default, we use the addition sign when decomposing, plus b over s minus 5. Next thing, you simplify the right hand side by finding the LCM, which is the product of the two linear factors. Next, you divide the LCM by the first factor, the result times numerator a. You have it in this form, plus the same LCM divide by the second factor, the result times numerator b. You have these results. Multiply through by the LCM to clear fractions. So you multiply through this term by the LCM, you are left with 3s plus 2 equal to, you multiply this term by the same LCM, you are left with the numerator. You have it in this form. Let's call the result equation P. We need to solve for A and B in order to have the partial fractions. The solution continues. We have equation P previously. In order to find A, you simply make this term equal to 0. To achieve that, this s must be replaced by minus 2, because minus 2 plus 2 is 0. 0 times b is 0. You do that in equation P. Put s equal to minus 2 in order to eliminate b in equation P. This is equation P. You replace s with minus 2. You have this result, that is minus 4 equal to minus 7a. This term is now 0. To get a, divide both sides by minus 7 and you have it in this form. To find b, you go back to the same equation P and make the term containing a to be 0, and that is possible if you put s equal to 5. This is equation P again. You replace s with 5 and you have this result, that is 17 plus 7b. To get b, divide both sides by 7 and b is equal to 17 over 7. Therefore, the given compound fraction that is equal to the partial fractions. To continue, you replace A with 4 over 7 over the linear factor plus B 17 over 7 over this linear factor. When you simplify, 7 will meet s plus 2 in the denominator. Same thing happens here, and you have 4 over 7 times s plus 2 in bracket plus 17 over 7 times bracket open s minus 5 bracket close. Example 2, decompose 2s plus 3 over 2s minus 1 in bracket s plus 1 in bracket into partial fractions by the method of comparing coefficients. Solution: you have the compound fraction, the linear factors are non-repeated, and as such you assign numerators to each one of them. So you have p over the first linear factor plus q over the second linear factor. When you find the LCM and simplify, you have this result. Next, you multiply through by the LCM to clear fractions, and you have this result as equation P. To compare the coefficients, equation P needs to be expanded. So you have 2s plus 3, p plus s is ps, p plus 1, that is p, plus q times 2s. You have 2qs plus q times minus 1, that is minus q. The terms that have s in common, you bring them together, and the constant terms p minus q, you bring them together. From here, you factor out s, the common term, and you have this result. Next is to equate the coefficient of s. That is, you compare this term with this term. They have s in common. When you equate, you have p plus 2q. The coefficient of s here equal to 2, the coefficient of s. That is equation 1. Next, you equate the constant terms. P minus q equal to 3, and you have equation 2. Next, we are to solve both equations simultaneously using any of the methods. Solve equations 1 and 2 simultaneously using elimination method. You have the two equations. I'm going to eliminate variable p. I will do that by subtraction. Variable p, the coefficients are the same in both equations, 1, 1, and the signs are also the same, positive, positive. You have to subtract. So p minus p is equal to 0. This minus sign will turn here to be positive. So 2q plus 1q is 3q. 2 minus 3 is minus 1. To get Q, divide both sides by 3, and Q is equal to minus 1 over 3. To solve for P, you have to substitute Q value into equation 2. This is equation 2. You replace Q with minus 1 over 3. If you open the bracket, you have this result. Transfer plus 1 over 3 to the right hand side to make P stands alone. If you simplify this fraction, you simply write 3 as over 1. Then you find the LCM and simplify. You have this result, and P is equal to 8 over 3. Therefore, you write the compound fraction that is equal to the partial fractions, and you replace P and Q with what they stand for. Plus minus becomes minus. You bring 3 down to meet the linear factors, and you have it in this form. If you divide 8 over 3 by 2s minus 1, you have this result. Same for the second term, which is equal to this. End of lesson 2. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.